Good morning, this is Dr. Turner for Integrated Math 3. Today we're going to be covering 5.2, which is graphing cubic functions. It's going to be very similar to previous sections we've done. Most specifically, it's going to look very similar to 5.1, which is graphing square root functions. So we'll go ahead and just jump right into it. This should be fairly straightforward, hopefully for everyone. So we're doing it in Desmos, of course, because we are online here. So if you pull up your Desmos, your cube root function is as so. Remember that to type in your square root or cube root, it's SQRT if you want to type in square root, and CBRT if you want to type in cube root. This is your parent cube root function. Unlike the square root function, which sort of looks similar, kind of looks the same, but square root only has 1/2 to it. That's because when we plug in a number inside the radical, we can't have any negatives because it would create an imaginary number. Cube root function is different because we can plug in anything and get a cube root. A negative times a negative times a negative is a negative, and a positive times a positive times a positive is a positive. So anything goes for cube root function. In mathematical terms, that means that our domain is from negative to positive infinity, and our range is also from negative to positive infinity. So you can write all real numbers if you're asked to define the domain or range, or you can use your set notation and do negative infinity, comma, positive infinity with parentheses, not brackets, like so. So that's how you would write your domain and range in set notation. Again, the title of this section is Graphing Cube Root Functions. So just like we just did in 5.1, 5.2 is going to look very similar. If I write out the full cube root function, it's going to be a times cube root of x minus h plus k. And just like on all the previous sections, what does k do? K moves it up. So if I have cube root of x versus cube root of x plus 1, it moves it up 1. To move it up 5, it'd be cube root of x plus 5. If I want to move it down, cube root of x minus 2, to move it down 2. If I want to move it down 4, cube root of x minus 4. K is always the same for all these function families. So any value on the outside is changing my output, so it's moving it up and down. Similarly, if I'm changing something inside or I'm changing the input, it's going to move it left and right. Remember, because that minus sign is there, it's kind of backwards. We're used to thinking of x-axis going left being negative and right going positive. But because I have a negative sign in my equation, it's backwards. So cube root of x minus 1 would move it right 1. Cube root of x minus 4 would move it right 4. And vice versa. Cube root of x plus 2 would move it left 2. Cube root of x plus 4 would move it left 4, etc. You're going to see the same changes with a. As I increase a, 2, 4, 10, it makes the graph increase more quickly. And so it shifts it. It's increasing by a factor of whatever that a value is. And if I have a value less than 1 here, then it's increasing more slowly. So it would change it as so. And of course, if I have a negative sign, it's going to reflect it, just like any other function family that we've talked about. Of course, you'll have these types of problems where I'm giving you describe a graph, shift it up 3, down 4, right 2, left 1, whatever the case may be. The other thing that I will do is I will show you a graph. Let's say something like this. You won't have the equation shown, and then you'll be asked to identify the equation of the graph as it's been shifted. So for instance, in this case, looking from the parent function to the new graph, it's been shifted to the right 3 spaces. So my answer would be y, or f of x, equals cube root of x minus 3. And similarly, let's say have something like this. I'm looking at the parent function. I see that the graph has been shifted up 4 spaces. So my answer would be y equals cube root of x, and then on the outside, plus 4. Those of you that have been following along on the videos, I hope this is going to be pretty straightforward because you guys have seen now that a, h, and k in multiple function families. If you have any questions, please reach out to me or attend office hours. Have a good day, and I'll talk to you soon. Bye.